Astronomers have made a remarkable discovery, a colossal cluster of galaxies that has been named in Hawaiian. The discovery of an enormous bubble located 820 million light-years away from Earth is attributed to the origin of the universe, according to a team of researchers led by the University of Hawaii. Astronomer Brent Tully and his colleagues from the Institute for Astronomy stumbled upon the fossil-like remnant while studying a cluster of galaxies. The bubble, which has been named Hoʻoleilana, originates from the kumulipo, a Hawaiian creation chant that describes the emergence of structure. As reported in the Astrophysical Journal, recent discoveries reveal that colossal structures like these were anticipated by the Big Bang theory. These structures were formed by 3D ripples, identified in the matter of the nascent universe, known as baryon acoustic oscillations, BAO. Tully provided an explanation, stating that they did not intentionally search for it. Its vastness was such that it extended beyond the confines of the sector of the sky they were studying. Tully went on to say that as an increase in the concentration of galaxies, it is an even more powerful feature than was anticipated. The diameter of 1 billion light-years is much larger than what was predicted. If this baryon acoustic oscillation's creation and development align with current theories, it would be closer than expected, indicating a high expansion rate for the universe. The discovery of the bubble was made possible through the utilization of data from Cosmic Flows 4, which is currently the largest collation of accurate measurements of the distances between galaxies. Tully co-authored the remarkable catalogue in autumn of 2022. According to Tully's team of researchers, this could potentially mark the first instance in which astronomers have been able to identify a singular structure correlated with a BO. This discovery has the potential to significantly advance scientists' comprehension of the impact of galactic evolution. According to the widely accepted Big Bang theory, the universe was an extremely hot plasma during its initial 400,000 years, similar to the Sun's interior. Electrons were separated from atomic nuclei within this plasma. During this time, areas with marginally greater density started to crumble due to gravity, while the intense radiation attempted to push matter away. This conflict between radiation and gravity caused the plasma to undulate, or ripple, and expand outward. During the primordial era of the universe, the size of the most significant ripples was dictated by the distance that could be covered by a sound wave. This distance, which was almost 500 million light-years, was determined by the speed of sound in the plasma. Once the universe cooled and ceased being a plasma, these vast three-dimensional ripples were established permanently. Over the course of time, galaxies formed in the density peaks, creating enormous bubble-shaped structures. The properties of these ancient message-bearers can be deduced by studying the patterns in the distribution of galaxies with precision. Daniel Pomeride, a researcher from CEA Paris-Saclay University in France, describes himself as the group's cartographer. He explains that creating a three-dimensional map of Hoʻoleilana was a crucial step in comprehending the content of the structure and its relationship with the surrounding environment. The process of constructing the map was a remarkable experience, as it revealed the intricate composition of Hoʻoleilana's massive shell structure, which is comprised of previously identified elements that were themselves some of the most extensive structures in the universe. In 2014, this group of researchers also detected the Laniakea supercluster, which encompasses the Milky Way. Despite this inclusion, Laniakea is relatively diminutive in size when compared to its counterpart. Its diameter spans roughly 500 million light-years, and it stretches as far as the border of the much more expansive bubble. During their investigation, Tully's group uncovered that Hoʻoleilana had been mentioned in a research paper from 2016 as the most notable among a series of shell-shaped constructions that were identified in the Sloan Digital Sky Survey. Nevertheless, the former research did not disclose the complete scale of the structure, and the authors did not assert that they had discovered a baryon acoustic oscillation BO. With the aid of the Cosmic Flows 4 catalogue, the team of researchers was able to observe an extensive spherical shell of galaxies. They were able to determine its center and note that there is an increase in the density of galaxies in all directions from this center. Hoʻoleilana, an astronomical phenomenon, consists of several renowned structures that have been previously identified by astronomers. Among these structures are the Harvard-Smithsonian Great Wall, which includes the Coma Cluster, the Hercules Cluster, and the Sloan Great Wall. The Bootes supercluster is situated at the core of Hoʻoleilana. Additionally, the historic Bootes Void, an enormous empty sphere, resides within Hoʻoleilana. Based on simulations conducted, tests have revealed that the shell structure known as Hoʻoleilana is highly unlikely to be a statistical anomaly with less than 1% probability. This structure has the characteristics of a baryon acoustic oscillation, which is a theoretical concept. Specifically, it contains a central supercluster that is rich in content, but it is more prominent than expected. Hoʻoleilana is slightly larger than what the standard model of cosmology theory predicts, and it deviates from the statistical pairwise galaxy separation studies. The size of Hoʻoleilana is consistent with the observed expansion rate of the universe and the flow of galaxies on a larger scale, both of which suggest issues with the standard model. To support our channel's growth and ensure broader awareness, kindly hit the like and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.